Hi students, and welcome to another week of distance learning. Today we are going to dive deeper into Entity Framework. Last week we started with the very fundamentals of Entity Framework, and today we are going to pick a few topics and take a closer look on how Entity Framework does its magic. How are we going to approach today's lesson? Just like last week, you will get this video from me and you can work it through based on your environment and your learning pace. Please start Visual Studio and follow along the examples that I show you in my Visual Studio. So whenever I type in code, try to follow along. Pause the video when necessary, try to understand what I do, and whenever it makes sense for you to understand more details about Entity Framework, set a breakpoint, use the debugger to inspect a little bit what is going on behind the scenes, write some additional lines of code, and just explore the topics that we are going to cover today. I will be present in Discord and Teams for individual questions. So if you don't understand a certain piece of code, if you want to know something that I do not cover in my example, or if you have individual problems with your environment accessing a database, for instance, don't hesitate to switch over to Discord or Teams and let's discuss your problems or questions there. And with that, we are going to dive right into the topic. We're not going to cover again what we did last week. You can re-watch the video if you have forgotten some things here, but we are going to build on the solution that I created together with you last week. For those of you who can't remember what we did, or maybe who were sick and couldn't follow, you can start with the exercise that I pushed on GitHub. Here let me see here in this folder, Entity Framework Intro, we have a small sample app that we created last week. And I will copy this sample app, and together we will build on top of this existing code and try to cover some more advanced topics. So let's get started and let's copy this solution to have something with which we can play. Here I have this Entity Framework introduction sample that I created last time, and I will just copy it. Of course, you can take your solution that you created last week when you were following along my exercises, but I will just take the one that is on GitHub. Now let's open this solution in Visual Studio 2019. Here we are. In this solution, we have a bunch of metadata, a bunch of demo data that we can get rid of. So please leave these two lines, the creation of the context up here, and delete everything else up until or down until, the modal classes. You can remove everything down to the modal classes. Please keep the modal classes because we will just use them as a basis for our today's experiments. Just to recap what we did last week, we had dishes. A dish has a title, notes, stars, and ingredients. And we have multiple ingredients for a dish. Here you see the ingredients. Down here, you have the database context, which we called the cookbook context, where we can query the dishes and query the dish ingredients. Last but not least, last week we created a context factory, a helper class, which we use to instantiate a database context. Please remember that we take the connection string from the configuration file app-settings.json. Here you can see it. Let me zoom in for you so you can see it better. Here you see the app-settings.json. Please, before you run the application, take a look at the existing app-settings.json and make sure that this one works for your local PC. If you just followed along last week, everything should be just set and everything should be fine. We can immediately take off where we left. Okay, so let's assume that the modal classes are present. The context works, the context factory works, and we will start our experiments up here where we have the cookbook factory. In fact, we don't need the context here. This is the only line of code that we currently need. Now, let's make a short experiment And in this experiment, I would like to create a new dish and update the dish. Let's do that. Let's create a new dish, and set the title to foo, and set the notes to bar. That looks good. I'm fine with that. Let's add this object to the data context. For that, I was wrong. I'm sorry. We have to create a data context here. So using var db context equals to factory dot create db context. Just like last week, nothing new so far. Now we can add the new dish to our database. db context. Let's write it with an uppercase C. I like that one more. Let's add it to the list of dishes. New dish. That looks good. And do an db context.save changes async. We covered that last week, so I will not repeat that. And now comes the interesting part, the part where I would like to take a closer look on the generated SQL statements and where I would like to go into more details so you understand what's really going on behind the scenes. And this part is updating the entity. I mean, this statement is pretty obvious, isn't it? The add command in C# leads to an insert statement in the database. Pretty simple, pretty basic stuff. But now let's change new dish the notes on our new dish object, Baz. And then we will do another save changes. Last week we learned that this save changes will update our notes in the dish table. But this week we will dive right into that one. Before we run this program, I ask you to scroll down to the nearly very bottom of your code and uncomment this line here. This line says use logger factory, and last week I told you that by uncommenting this use logger factory here, we are going to see the SQL statements that are generated while running Entity Framework code. So it makes it easier for us to understand what's going on the database side. Okay? So please scroll down and remove the comment for the use logger factory. And with that, we can set a breakpoint here for the save changes, the second one, and run our code in the debugger. Let's try this. Let's run it in the debugger. The debugger comes up, a bunch of logging appears, and now we are here in the save changes. Remember what we did. We just updated the notes on our new dish object. Let's run the save changes async, and then let's take a look in the generated SQL code. Here you can see the SQL code, and the important thing that I would like to draw your attention to is this one. Somehow Entity Framework managed to recognize that we just updated the notes. It did not update the stars, it did not update the title, it did not update the ingredients, just the notes. How did it do that? How does Entity Framework know that we just updated the notes here? That's not a trivial question. As you might know, C# does not store magically a history of all changes to a C# plain old CLR objects, also called POCO. This is a POCO, plain old CLR object, nothing special. Just a class with a bunch of properties, no history store hidden behind the scenes, nothing. We just change a property and then we say, hey, database context, whatever I changed on any object that is currently in memory, magically write everything to the database. I often call this, you know that already, Harry Potter programming, a little bit of fairy dust, and Entity Framework just makes everything magically happen. How? This is not obvious, and this is what I would like to explore a little bit more in the next few minutes. For that, we are going to write a small method, a static async task, and let's call it entity states. Why we call it entity states? You will see that in a second, okay? We have the cookbook context factory. This is what we want to have, and we want to have this as a parameter. So please Oh, I'm missing a using statement here. So control dot gives me this nice little helper IntelliSense here. I just press enter and I have the system threading task appear installed. That looks good. Now we get in the factory and let's call our helper or our experiment method here, pass in the factory, as you can see it here, and await it. Now we can do our stuff here inside of this method. Here I would like to show you what's really going on behind the scenes and what Entity Framework is really doing in order to make this magic up here happen. Good. Let's create a new database context on which we will do our operations. Okay. Using var db context equals to factory dot create db context. Good. We have a database context. Now, let's create another instance of this new dish. I will copy this line of code here, this one, and add it here. And now comes the new part, the first part of the new part. If I take the db context, this one, the db context, this one, I can use a method which is called entry to get entries inside of the so-called change tracker. This is a hint of how Entity Framework does its magic. Behind the scenes, it has a change tracker, a mechanism which tracks changes to objects that it already knows. So we can ask db context to tell us what it knows about our new dish. Every entry in the change tracker has a state, as you can see it here. Let's write this state in a variable so we can easily explore it in the debugger. So let's set a breakpoint here at the last line of our method. We can remove this breakpoint up here and then let's run the code until this line here. If I hover over state, I will pin it here on the debugger side. You see it? I will put it here. Then you see that the current state here that Entity Framework has about our new dish here is detached. Detached means that Entity Framework tells us it has no idea what this new dish is all about. It didn't come from the database context. We did not read it from the database. Entity Framework has never seen this dish. And therefore, the state of this object in terms of Entity Framework is currently called detached. Now, if I add this new dish to my database, let's do that. Dishes, add new dish. The state will change. Let me copy the state down here and let's see how the state looks now. Because now Entity Framework has knowledge about this object. The object has not been written to the database. That is important because we didn't call which method? Correct. Save changes async. As long as we don't save changes, the changes are only recognized in memory. So with the add method, we just add a plain old CLR object to Entity Framework's change tracker. And if we call save changes afterwards, we will do that in a second, then the change tracker will go through all its entries and will generate the appropriate insert, update, or delete statements. Now let's try to find out what the state is after we add a new object to the change tracker of Entity Framework. Let's run it in the debugger. And we will see that the state is now, you see it here, the state is now added. So we went from detached, what we had before, by calling add here. This brings us to the added state. So let's note that this is now added. So we know the change tracker has a new object which is added to the change tracker. And now we call save changes async. We can copy the save changes async method from here. And again, we will inspect the state after we call save changes. We don't know what the state is now. So let's take a look what changes in terms of the change tracker when we call save changes async. Run it in the debugger. And we are here, and now we have a third state. Here you see the state. It's unchanged. So it went from detached. Entity Framework says, I have no idea what this object is all about. Then we call add, and this changes the state to added. Entity Framework says, okay, I know this object. I haven't written it to the database, but I know of this object. When you call save changes, I will make sure that it finds its way into the database. And when we call this save changes, we have the next state, unchanged, because now Entity Framework tells us, okay, I know this object and I have written it to the database, therefore it is unchanged from my side. Everything is fine. So let's note that down. Unchanged. Good. Now what happens if we modify something in this object? Let's say new dish.notes equals Baz. That's the change that we did before. Now again, let's inspect the state after we made a change to an object which is already tracked by Entity Framework. Let's run it. Oh, I didn't remove this one. This is wrong, of course. This is wrong. We are just questioning what is the state now. And here you see the state. The state is now modified. By just changing a property on our plain old CLR object, Entity Framework recognizes that we changed something. How does it do that? How does it recognize the change? Does it somehow magically attach a kind of event handler that gets notified when you apply any changes? No, it has a different mechanism, and I will show you this mechanism in a few minutes. But before I show you how Entity Framework does its magic, I would like to stay a little bit longer here on these states, because now we know that this is modified, but we have not, let me note that down, but we have not taken a look at the third option that we have, not just adding and modifying, but also removing. Let's try the removing experiment, and then I will show you how Entity Framework does the change tracking internally, okay? So with that, let's do another save changes. We already know what's happening after a save changes. It is changed from modified to unchanged again. We already know that. But now we are going to remove our record. So we say db_context.dishes.remove and say new dish. So the dish that we just inserted is now removed. And now it is again interesting because we are going to take a look what the state is now, after we have called remove. So let's run this guy. And what is the state? You see it here. Not a big surprise. The state is now deleted. So we have detached, no idea what you're talking about. Edit, oh, you edit something, but I haven't written it to the database. Unchanged, okay, I've written everything to the database, no changes that I currently know of. Modified, there are outstanding changes. I have something to update in the database. And with the remove, we are changing the state here to deleted. So we can note that down here, deleted. This is the next state that our entity goes through. And finally, we can call the save changes again, and let's inspect for the last time the state. Let's run this guy. Okay, and the state at the end is detached again. So we can change that one. It's detached. Why? Well, the new dish is no longer part of the database because we have removed the dish. So if you take a look, we started with detached before we added the object to the database, and we ended with detached because in the middle we removed the entry from the database. So these are the entity states which you can go, which an entry can go through while working with Entity Framework. And you should remember this method entry here because it is really important and it gives you access to all the change tracking information that Entity Framework gathers behind the scenes. By the way, this behavior, this change tracking behavior is on by default. You don't need to enable it when working with Entity Framework. However, there are situations where you might want to disable change tracking because of performance reasons. I will tell you more about such situations in a few more minutes, okay? But for now, don't worry. The behavior that I showed you now with Entity Framework is the default behavior which you can expect when just working with Entity Framework out of the box. Performance optimizations are a different thing. We will definitely take a look at such examples a little bit later on. Good. What else can we do with this change tracking information? Let's start with a new function, a new experiment function, where we take a closer look how Entity Framework really does its magic behind the scenes. So let's create a new method, static async task of, this one here, change tracking. And again, we take the cookbook context factory as an input parameter exactly like before, and we say using var db context equals to factory creates db context. Okay, just like before, but let's call this guy await change tracking factory. Good, we are ready to do our next experiments here. Whenever you need, don't forget, whenever you need, pause the video and try to follow along. So do not just watch the video. You have to type in the code, you have to run the debugger yourself in order to really remember what we are doing here. Just by watching me typing, you will not get the most out of this lesson. This is the reason why I do it in a video, so everybody can work through the material or her or his correct timing, just like it fits to your existing knowledge and experience, okay? Good. Let's create a new dish. We have done this before. Let's do it again. Here we have a new dish, and let's add this dish to the database. I'm just copying statements here, what we did before, and let's do save changes, this one. This is easy. We are just adding another sample row to the database, nothing special. Then again, let's do a change. Okay, so I copy this one with the baz here, this one to this one. Now we updated our newly added dish. Now comes the interesting part. This is just the same code that we have written before. Let's do the following. Let's see var entry db context.entry. We have used this entry before. This is exactly the entry that we used in our previous experiment. You see it here to get to the state. But now I'm storing this object into a variable in order to be able to take a closer look on what this entry can really do. If we take a look at this entry, we get a bunch of interesting properties and methods. I don't have the time to dive into all of them. You can take a look at the details in the documentation. I would like to specifically take a look at the original values property. Original values, and here I will add name of dish dot, what did we change? Notes, this one. And then I will say toString, and here I will say var original value. Maybe the word original value already points you to the solution that Entity Framework has for change detection. What it does, it always saves the original value that it knows that came from the database or has been written to the database previously. So in the original values, Entity Framework gathers the original values as they are in the database, and when we change something on the plain old CLR object, and when we call save changes later on, it simply compares, let me zoom in here, it simply compares the original value and the new value, which is in the C# classes. It checks the differences between the thing that is currently in memory and the thing that is in the change tracker in the original values. And if there is a difference, it knows that the data has been updated, it has been modified. It can check for each property what the original value is and what the new value is. And with that, it can build the correct update statement that is run against the database. Okay? Let's try that. Let's set a breakpoint here. And let's inspect the original value. What I would expect is that the original value is still bar, because this is what we saved to the database here. And the notes, the current value should be baz. And with that, you understand that? It recognizes that something has been modified. Let's run this guy. And here we are in, oh, I don't need this breakpoint. I want to run to the second breakpoint. And yes, here we are. You see it? Oh, that's not easy to see. Let me quickly pin this guy here and put it maybe here and zoom in a little bit. Here, this is the original value, okay? Bar. It came from here. The new value is baz. And with the next save changes, it will write the new value, only the node's new value, because here we have the difference between original value and current value. I hope this makes it a little bit clearer how Entity Framework detects changes and generates update statements. We are nearly through with this example, but I would like to show you how this change tracking is very much connected to a single database context, and you have always to keep that in mind. You might currently not know what I mean with a single data context. Let's wait for another few minutes, write some lines of code, and then I'm pretty sure you understand what I mean. Because what we will do here now is we will create a second database context. See? I will just set up a new database context. Let's call it DB context 2. Okay? In this DB context 2 here, this one, we will now try to read, let's say we will read the dish from the database, var dish from database, and we will say DB context 2 dot dishes dot single async d goes to d dot id equals new dish, that's the dish that we added to the database, dot id. Okay, that will read our dish from the database, and I will do exactly that statement here and here. But up there, I will use the original data context, and down here, I will use the second data context. Let's put a 2 here too. And then we will compare these two things and think about why the world is as it is. Let's run it. Okay, now here, I will clean up a little bit. The dish from database, let's put it here. I forgot something. I'm very sorry. I have to say await here, of course. I forgot the await. I'm sorry. Let's run it again. Good. Now here you see the dish, and I will pin the dish from database nodes here, and here I will also do a pin here, and I will again pin the nodes here. Good. Now let's compare these two values and think about why they are as they are. Let's first focus on the first result. The interesting thing here is that we read the dish from the database. We reread the dish from the database because we added it here, and we were just filtering on the primary key, as you can see it here. But the interesting thing is, and please keep that in mind, that although we are rereading the dish here with this single async, we are not getting back the original value bar, but we get back the new value baz, which is only the value that we have in memory, and we didn't save it to the database. So the important thing is, when you ask Entity Framework to read data from the database, and it knows that this data is already in its change tracker, the identification is done based on the primary key, it will not give you back the value from the database, but it will give you the value from its change tracker. And therefore, even unwritten changes, like this one, baz here, are returned when you use a query which returns some data from the database. In the second example, we are using, here you can see it, a separate data context. And when we do a single async here, we will not get back baz, but we will get back bar. Because this data context down here has no idea that there is an object up here which is tracked by the original database context. So the whole change tracker thing is not a singleton across all data contexts, but the change tracker is really specific for each data context. And this is important. If you have in your application multiple data contexts, you can be sure that changes are only written to the database with save changes async, which you did to this specific database context. If you need to do something else independently, you have to create a second DB context, and when you call save changes there, it only writes its changes to the database. So the database context isolates the changes and always knows which changes to write to the database. That's not that easy. I know that. I hope you understood what I mean. When we go to ASP.NET and web APIs, we will definitely go back to this, and then you will have an even better understanding of what it means, change tracking by database context. But for now, you got a little bit of an idea of how it works. Some of you might even have fully understand it. If you haven't fully understand it, but you only have a rough idea, that's enough. That's good. A rough idea is fine. We have still some weeks to work on Entity Framework. If it's completely unclear, go to the Discord server or to Teams, and there we can discuss your questions, or I can help you debugging your code so that we can find out what's really going on behind the scenes to make sure that you understand what is meant with this change tracking and this data context isolation. Good. That's good. We have our entity states, this one, and we have talked about change tracking. I showed you that we have the original values, and we discussed various scenarios with different database contexts. Let's go to another topic that we have, and this topic is attaching entities. We are still in the context of the change tracker. So no completely new topic now, but just another angle on looking on the change tracker, okay? Now let's copy again our method here This time we will call it, let's call it attach entities. Let's put it that way and call this guy here await attach entities factory. Okay, that's good. Yep, I like that. Now let's copy a little bit of code. We will copy the create database context, the new dish, the add, and the save changes. That is good. The question that I ask here is, can we make Entity Framework somehow forget an object that it already knows? Can we tell the database context, hey, database context, the object that you have in your change tracker, forget it. It's not your job anymore. Forget about it. Make this object just like you have never seen it before. And the answer is yes, we can do that. We can force Entity Framework to forget about entities that it previously knew. So let's do that. Let's say dbcontext.entry, we know that already, new dish, this one. And then we can say state, but the important thing here is we can not only read the state, but we can also write the state and say, hey, Entity Framework, the state of this object is now detached. That means Entity Framework, forget about this object. It's not your job anymore. Sometimes this is useful. Yes, and there are scenarios where you need exactly that. Of course, you can not just change it to detached, you can also change it to modified and things like that, but that's a different story. We will not go into details here. So this is Entity Framework, forget the new dish object. Do like you have never seen it before. Let's take a look whether this works, okay? Let's set a breakpoint and run the app. And here we are. And if we take a look at this one here, let me quickly call the quick watch where it is. Here is the quick watch. Then we will see that we get an exception. Exactly. That is what is expected because new dish is no longer part of the change tracker. So therefore, it's detached, it's unknown. If we take a look at the state here, I've not saved it here, but yeah, should we? Yeah, let's get it. So let's say state var state equals to, let's read the state and let's check whether it works. Here we are. The state is, as expected, detached, exactly like we had it before, just as if Entity Framework has never seen this object. Now, imagine a situation where you have exactly that. You have an object that did not come from Entity Framework. Imagine, for instance, you are writing a web API and somebody sent you an object, a customer, an order, or in my case, a dish via HTTP into your web API. Now this object, in our case new dish, is completely unknown to Entity Framework. Can we still work with this object? Can we, for instance, say dbcontext.dishes.update new dish? Now that is kind of interesting because the update method, why do we need an update method here? Previously, I've shown you that we can update something by just assigning a value to a property. Why do we have to call update here? Well, the point is that this update method here will take an object which is not part of Entity Framework change tracker and add it to the change tracker. It adds it to the change tracker, but if we call, let's do that, dbcontext.savechangesAsync, and if we then take a look at the generated SQL statement, we see something pretty astonishing. You see it here? Because Entity Framework does not know that this object already came from the database. It has no idea which of the properties might have changed. And therefore, if we give it an entity, an object that it doesn't know previously, just to make sure, Entity Framework will overwrite the entire object in the database. It will not diff the changes. It will not read the object and then find out what has changed and only update those things that have changed that we have seen before. But because we add the entire object to the change tracker, it overwrites the entire object. So this is very useful, and you will see this technique calling update on an object which is previously unknown to Entity Framework. You will see that later in the year when we build ASP.NET Web APIs, where we get our objects over the HTTP protocol in the JSON format. Okay? This is important. This is attaching entities. Last but not least, I want to show you the last experiment related to the change tracker. Let's call this experiment no tracking. Okay? And call this experiment no tracking factory. Good. And inside of this no tracking, we again create a database context. Good. Now, if we would like to get all dishes from the database, how would we write that? Var dishes equals to await db context dot dishes, no where clause. We want to have really all of them. So we just say to array async. That is the analogy to a select star from dishes as we would write it in SQL. Okay, let's set a breakpoint here and let's check in the output of if I'm really correct. So if I go here, then you will see, oh, I'm sorry, I did, this is the wrong breakpoint. I have to run it now. I'm here. And if you take a look, well, it didn't write a select star, but as you can see here, it included all the columns, ID, nodes, stars, title. So it is essentially a star, select star from dishes, just as I told you before. So this is what's happening here. But what's also happening here? By running this statement, all the dishes from the database table are added to the change tracker. So Entity Framework stores all the data that came from the database a second time. It is not just in your collection here, but it's also stored in the original values in Entity Framework. And that's quite a bit of overhead. It's necessary because we want Entity Framework to do its magic and generate proper insert, update, delete statements. Therefore, it needs to understand what has changed, and therefore it needs a change tracker. But what if in this scenario we don't need to track changes because we are not going to do any changes? Maybe we will just take these dishes and use them as the basis for some kind of report, or just print them, just generate an HTML page, for instance, with all these dishes on it. We will never ever make any changes to these objects. Can we tell Entity Framework that we are not interested in putting these objects into the change tracker? The answer is, of course we can. In this case, you should always, just before the toArrayAsync or toListAsync, call the as no tracking here. As no tracking means that the dishes that are returned here are not added to the change tracker. So if you would do some changes here and call save changes async, nothing or bad things will happen because they are not tracked. That's the point here. Okay? So if we take a look at the state, let's do that one here. And let's not say the new dish, but say dishes 0. Let me quickly check whether I have some records in the database. Yes, I have records in the database, so it should return something. If I run this guy, then everything should be fine. And if I take a look at the state, you see, although this dish came really from the database, the state is still detached because we called it with as no tracking. So this is an important thing if performance matters. And performance should always matter to a certain extent. If you only read something from the database and you don't intend to change the object, always add something like as no tracking. There are additional methods with additional parameters. You can read the details in the documentation, but for this course, you just have to remember as no tracking in case of read-only scenarios. Good. We spent the first hour talking about change tracking. What are the most important things that you have to remember in order to pass this course? You definitely have to understand what these entry states are all about, because maybe not now, but in a few weeks when we do ASP.NET Core programming, we will definitely need to talk about these states again, and you will need to be able to apply these states and to understand what the states are. You should have a basic understanding about change tracking. I will maybe ask you in an exam, in a theory lesson, how does the change tracker in Entity Framework recognize that a certain property on an object has changed? And your answer should be, Entity Framework remembers the original values which came out of the database, and by comparing the current value of the objects with the original values stored in the change tracker, it recognizes which properties have changed. So this is something where you should remember the concept of how the change tracker works with original values. The attach entities area here, you don't need to remember that yet, but we definitely will need that when we come to ASP.NET Core, but I will remind you, don't worry. The last thing which is more important currently is the as no tracking, because in the next exam, I will maybe ask you to write a little bit of database code, and then when I take a look at your code and I will calculate your grade, I will definitely check whether you applied as no tracking for those queries where you just have a read-only scenario and you do not need and don't want to write anything back to the database. If you forget the as no tracking, it's fine, it will work, but it will not be as performant as it could be. So remember the as no tracking. With that, we have covered the first topic of today's lesson. So now it's a very good time to take a short break. So maybe pause the video. If you have some problems understanding the material, come to Discord or Teams and ask me. Otherwise, fetch something to drink, take a short break, and in a few minutes, come back and we will continue with the next topic. Welcome back. Welcome back after the break. We covered before the break the change tracker, and now we are going to start with a completely new topic related to Entity Framework, executing raw SQL queries. For that, we will write another experiment method. So let's just fold these methods and add, I will add it up here, add another experiment method. Let's call it raw SQL. And let's call this experiment await raw SQL factory. So we can have a little fun here with Entity Framework. First thing, again, we will create a database context just as we did before. And now I would like to show you how you can execute raw SQL statements, because sometimes you need exactly that. Entity Framework is pretty smart in generating SQL statements for you. But sometimes you really want to go down to the metal. You want to write every single letter of the SQL statements on your own, because maybe you have to use a specific feature of the underlying relational database management system, something like, I don't know, a with clause in a SQL query with Microsoft SQL Server, for instance. Something like that. is not completely possible in Entity Framework, and therefore you have to have a possibility in those rare cases to write the SQL statement on your own. And Entity Framework fully supports that. Let me show you how this is done. What you do if we want to query some dishes with the raw SQL statements is you go to the usual dbcontext.dishes here, and then you have a method which is called from SQL raw. This is the first method that we are going to take a look at. And now here I can write select star from dishes. I can write a handwritten SQL statement, and from there on everything works as usual. So this is the beautiful thing here. I am still in the world of Entity Framework, so I will still get back some dishes objects. I can still use async programming. I also still have the change tracker, so the objects that are returned here are tracked by Entity Framework's change tracker. But I can tweak, I can optimize every small little piece of SQL by just specifying the raw SQL here. Don't get me wrong, this should not be your preferred way of writing SQL queries. Your preferred way of writing SQL queries is still LING, Language Integrated Query, but in every non-trivial application that I know, you have some situations where LING is not sufficient. Let's set a breakpoint here and run this guy, and let's see whether it really works. We are still here on the wrong breakpoint. Let me get rid of this breakpoint and continue on. And if you take a look now here in the log, here you see that we have now handwritten the SQL statement. So the characters that we typed in found their way into the SQL database. And if I take a look here in the dishes, you still see that we get nice little plain old CLR objects with all the things that we specified. Okay. This is what we get from SQL raw. First option. Next option. Sometimes you cannot just have as a constant SQL query. Sometimes you have, for instance, some parameters. Let me show you what I mean. Var filter equals to %z, and then we will copy the statement from up here. But this time, I'm going to say from SQL interpolated. Now, what is SQL interpolated? It expects an interpolation. Interpolation is the C# feature with a dollar up here, where you can use these templates, string templates. So you can say where notes like, and then you can specify here the filter parameter. Understand what I mean? So in this case, the filter parameter, it might be an input from the user. So maybe the user has selected that the user wants all the notes that end with a Z, because the percentage is a wildcard character here. It means anything, any characters before and at the end I want to have a Z. Okay? And this from SQL interpolated, it takes the filter that the user maybe has entered in a web form or maybe in a WinForms or WPF app or console app and inserts it exactly here. Let's try that and let's take a look at the generated SQL query. Good. Let's zoom in, and if you take a close look, then we see exactly here that we have the like statement, and this time it didn't take the constant %c and built a kind of string representation, but it still used a so-called parameter. And this one here is super important. This is the correct thing. Let me show you the worst thing that you could do, the worst thing ever. So if I take this command here, and if I say from SQL raw, and I say from, oh sorry, not from, where notes like, and then, oh, let's stick with the uppercase letters here, something like this. This is bad, 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 bad. This is bad, bad, bad. This is called a so-called SQL injection. You should never, never, ever write code like that. Yeah? A kitten dies whenever you write code like that. 1,000 kitten dies if you write code like that. So don't do that. Let me show you why. If I run this code and we take a look at the generated SQL statement here, then you will see that we now have the parameter which might have been supplied by the user. So the user has an entry field and the user can enter something there. And we end up with the user entry injected into the SQL query. You know what I would do as a user? I would simply say, let's do something like that. Drop table XYZ. This here is now injected into our database. Understand what I mean? So I can try that. I can say delete from dishes, something like that. So if I run this guy here, yep, let's take a look. So this is what we now executed. So I just deleted a lot of data from the table called dishes. And that's definitely not what we wanted. Understand what I mean? And this is why we call this a SQL injection. If you take a look at that one from SQL Interpolated, it works completely different because here the filter becomes a parameter, a SQL parameter. If I specify something like this, it looks for a note containing the text delete from dishes. Delete from dishes is never part of the SQL statement. So remember that. It's bad, 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 and you should never, ever do that. Okay, of course, all the other things work just as expected. So don't forget that you can do something like as no tracking if you don't need tracking information and things like that. Last but not least, let me check that one. Okay, everything's fine. Let me check this one. I would like to show you a raw SQL statement. Writing data, not just reading data. That will be our last experiment here with the raw SQL. With writing raw SQL, it works like that. You say await dbcontext.database.execute SQL raw, and then you can specify any writing statement, something like delete from dishes where ID not in select dish ID from ingredients, something like this. So we are using a delete statement here to write data. And finally, what's the problem here? Let me see. Int does not execute data db context. Let me see. Something is not good here, and I can't see it. We don't have any parameters. Execute SQL. Oh, async, of course. Of course, I'm very sorry. Async. This is what I've got here. Now it should really work. But yeah, let me get rid of that one. It was just for demo purposes, and you should never, never tell anybody that I've written that code. We don't want to do that. So let's get back to this execute SQL raw async. If I run it, if I go down here, you will see that we now executed a write statement, in this case a delete statement to the database. So it was pretty simple to delete all the data from the database, and if I run this again, data is gone, just as I expected. So what should you remember from this short demo? Remember that you can use from SQL raw if you have a completely constant SQL query. Use from SQL interpolated if you have a query which contains some parameters. And last but not least, use execute SQL raw if you want to execute a statement that writes data but does not return rows like in a SQL query. And never forget, this is very, very bad SQL injection. It has to stick in your mind that you never ever try or do this mistake. It will lead to very serious consequences if you do. Good. That is what I wanted to show you with raw SQL. So let me put the code here. Take the time, write the code, do the experiments, maybe take a sip from your glass of water and be back in a few minutes. Then we will continue with transactions. See you in a minute. Welcome back. Let me quickly remind you, if you have any problems or questions regarding the concepts or the code, please don't hesitate and come to the Discord server or to Teams meeting and we can discuss your problems or questions there. I'm waiting there for you. The whole idea of this way of teaching is that you can work through the video on your personal pace, and whenever you have problems, I can concentrate on helping each one of you individually, okay? So don't forget that. We will now continue with the topic of transactions. Transactions are luckily not that complicated with Entity Framework, so we will be rather quick and let's see what's going to happen. You know the drill so far. We will create another helper method. I'll copy these 3 lines of code, close it here, rename it, let's call it transactions, and call this guy await transactions with the factory. Good. This is now our playground for playing with transactions. Let's do something which is very simple. Let's add a sample rule, db dishes, add new dish, and let's add title, again, foo, and notes is bar. Okay, good, an add. Let's save our changes. db_context.save changes async, and don't forget the await statement here at the beginning. Good. After this save changes, we do another statement, and I can quickly take a copy of this execute raw SQL, something like this, and now I will do something really bad. I will say select 1 divided by 0 as bad. 1 divided by 0 is not a good idea. It will obviously result in an error. But the point is, why I'm doing that is that I would like to have a database transaction across the entire sequence of operations issued against the database here. So either everything now marked in blue is written to the database or nothing. That's the point of a transaction, okay? And I would like to show you how you work with transactions with Entity Framework. The first thing that you do is you put your entire code here into a try catch block in order to catch the exceptions, SQL injection exceptions. Yeah. If we have a problem, we will just print something on the console, error.writeLine. Something like something bad happened, and let's put the message here, exception message. Okay, looks good. Good. Now we have a try catch block, but this does not prevent us from writing this row here into the database, even though afterwards an exception happens, okay? So what we would like to do is we would like to span a transaction over the entire try case, over the entire try block. And we do that like that. We say using var transaction equals to db_context.database.begin transaction async. See? Don't forget to await, of course. This will start the transaction. And when we are done, we will say await transaction.commit, async, of course. Now, let's zoom in a little bit and discuss that. Here, we are starting the transaction. This is our transaction block. we want to either write it completely to the database or not at all. And here we have the commit statement. So if the code with the commit statement is reached, everything is written to the database. But in our case, something bad will happen. So the code will jump out here. The code will jump out here. It will go down there. Wrong direction. It will go down here and continue with the exception that you see here. So the code, because of the exception, will never reach the commit statement, and therefore the transaction will get out of scope without us having called commit. And that will lead to a so-called rollback action. You heard about commit and rollback in your database classes. Rollback means that the entirety of all change operations to the database are rolled back, are undone. And therefore, even the first add statement, although we call save changes as sync, will never be written to the database. So this is very typical code where you have a sequence of database operations which belong to a common business transaction, and you put it into a transaction to either write it in its entirety or not at all. Not that difficult. I hope you understood what we did here. You should definitely remember how you work with transactions, because it can easily happen that during one of your exams where entity framework is an important topic, I will give you some kind of exercise where you have to use a transaction to recover from errors, for instance. Good. That was a quick one. Transactions, we are good on that. Now, we have a few more minutes time, I would say half an hour, maybe a little bit less. So for the last half an hour, I would like to discuss a little bit how querying works, because we talked about the change tracker. It was about writing data. We talked about transactions. It was about writing data. Parts of raw SQL was also about writing data. But I would like to spend the last 30 minutes or so talking about reading data. And now comes the important part. The thing that I show you now, you don't have to remember the details for this course. It's pretty complex, what I'm going to show you now. You have to, it would be ideal if you take away at least the basic concepts of what I'm going to show you here. Don't worry. The thing that I'm going to present now will not be part of any upcoming exam in this year. Maybe this is something for the pros, okay? I can't expect that you understand and use all the things that I'm going to show you now, but it would be a good idea if you try to understand the concepts, because if you understand these concepts, it will be much clearer why Entity Framework behaves like it behaves, okay? It's also, for the last half an hour, not absolutely necessary that you follow along typing the code. You can also watch me typing the code and try to understand the concepts. But I encourage everybody who wants to become a professional programmer, a real professional C# programmer, try to follow along, try to type in the code and play with the code. Okay? So, warning set. With that, let's take a look at so-called expression trees. Static async task, expression tree, you know the drill. Cookbook context factory, there it is, factory. Let's create using var db context equals to factory dot create db context. We are good with that one, and let's call the expression tree method with our factory, and we have our playground. Here we can start doing the interesting work. Again, you already know that. Let's add maybe a little bit of data. Let's add our new dish and let's save the changes. Good. And in the middle, of course, we have to add the data. Good. Looks good. So that gives us at least one data row inside of our database. Now, let's write a small, little, nice query and then think about how Entity Framework can do what it does in terms of querying data. Var dishes equals to await db context dot dishes dot where. And in this case, I would like to say, give me all the dishes where the title starts with an F, okay? And then we will keep it simple. We can just say to array async. Really nothing special. Okay, let's set the breakpoint here and run this guy. Oh, we don't need that breakpoint. I am interested in that one. Let's take a look at the query, oops, that was generated by Entity Framework. Let me put it here. And let's zoom in a little bit. Let's see whether, no, yeah, I can zoom, yeah. Please take a look, especially here and here, starts with. And now let's take a look at this SQL statement. And please note the where clause here and recognize that the starts with method call here is translated by Entity Framework into a like clause with f percentage. I told you before that the percentage value here is a wildcard. So like f percentage results in exactly what C# starts with does. Give me all the titles that start with an F and are followed by 0 or n other characters. This is what we do here. The question that I would like you to ask yourself is, how can Entity Framework do that? Let's quickly think about what's happening when we write such a link query. This link query here on the left-hand side is translated by the C# compiler into intermediate language. And this intermediate language is then compiled by the just-in-time compiler to assembler language, and then it is executed somewhat in memory. You could think that this is the case. But in our case, this is no longer true. Somehow, magically, the Entity Framework jumps in and prevents this statement from being compiled to machine language. It doesn't make sense that this statement is translated to machine language because we need to translate it to a different language. We need to translate it into SQL, into this representation. So somehow, in some way, Entity Framework has to have the possibility to inspect this C# code and from this C# code understand what this C# code means and translate it to SQL. The question is, where does this happen and when does it happen? You could think maybe that this is done when compiling your C# application. Maybe Entity Framework somehow jumps into the C# compiler and says, hey C# compiler, I'm Entity Framework and I would like to translate together with you this link query. Chill out, you don't need to translate this one to machine language. I will translate it to SQL. You could think that Entity Framework works this way, but it doesn't. It does not compile your query at compile time. So the C# code is still compiled by the C# compiler. And then at runtime, somehow, magically, I will just show you how, Entity Framework manages to translate the compiled C# code into SQL. How is that done? Let's take a look at that. I will pick out just this content of the where clause here. Let's copy this one out. A few weeks ago, we talked about functions and actions and things like that. And now let's remember how this worked. We had this type which was called fun. And if you take a look at this thing here, it is called, can you remember, it is called how? Correct, lambda expression. So this is a lambda expression and the type is D is the dish, and the where clause needs a Boolean parameter in order to do the filtering. So it is a func of dish and bool. Let's call it f, and then we can just add the lambda method here. This is what we typically know as a lambda expression, okay? And this is what we have used over and over and over again in the first few weeks of this course. We are fine with that. But if we run this method again, or run this in the debugger again, and if I hover over this F, then you will see, oh, I cannot zoom in here. I'm sorry. I hope you can see that too. No, okay, I cannot draw here. We'll keep it like that. Then you will see that this F is just a method. It's a compiler generated method name, a very strange name, main $B and so on and so on. It's a method which has been compiled to intermediate language and from intermediate language to machine language, and believe it or not, Entity Framework has no idea how to translate this method into SQL. It cannot take a look into intermediate language and machine language and somehow magically get out the call of this starts with method and interpret it into a like query. It doesn't work like that. In the background, C# has a different concept here. Let's copy this line here, this one, and let's put an expression of func of around this guy and rename the variable. We will need a using statement here, and now we have exactly the same lambda method 2 times. We have it here. Let's put it that way so you can really see that it's exactly the same, where the variable is declared to be a function of something. And then we have it for the second time here, where this x variable is declared as being an expression of function. And let me show you in the debugger what a huge difference this makes. Let's run it. Let's hover over X here, and now we see something which is really impressive. Okay, I cannot zoom in here, so I have to leave it like that. This X compared to the F is no longer a method. You see, F is a method, it's compiled code. But if we take a look at the X, somehow the debugger during runtime can tell me what the original C# code was, what I've written. So with this expression thing, the Entity Framework has a chance to take a look at the code that you have written in C#, but take a look at this code at runtime. We can try to inspect this a little closer. You see this X, it's a so-called lambda expression, and it has a body. You see that one? We can open this one up, and we will see that C# at runtime, not at compile time, tells us, hey Rainer, this thing calls a method which is called starts with. I can take a closer look and can say, what is the object that I call it on? Well, the object is in this case a member access, because d.title is a member access. And which member is accessed? The member called title. You see? Expression of function of something means that the C# compiler is no longer generating machine language, but it is generating a so-called object tree describing the C# code that you have written, and tools like, for instance, Entity Framework, they can inspect this object tree at runtime and translate it into a different language, in our case, into SQL. So Entity Framework really takes a look at this X and somehow recognizes that this calls the start with method. And it has logic built in that says, the Entity Framework, whenever you recognize a string that starts with, then please translate this into a like f%, like something percent. That's the point here. The magic are these expressions. And when you take a look at how these, for instance, how the where clause here, how the where statement is defined, I can press F12 to go here, then you will see that this where clause takes exactly what I just told you. It takes an expression of function of. That means that this where clause says, I'm not interested in the compiled code, compiled down to machine language. but I am interested in an object tree where I can take a look at the object tree and translate that to a different language, in our case, SQL. If we don't have a database table behind the scenes, so if I copy this guy here, this one, and I just var in-memory dishes, and I just create an in-memory array of, let's say, again, dishes. Let me quickly generate some demo data here, okay? Now I have an in-memory representation, and this time I will not go to the database, but I will just say in-memory dishes. Please note that here the lambda and here the lambda are exactly the same, but here we have entity framework behind the scenes with all this expression stuff. And here I have classical in-memory link with an array of something without a database behind the scenes. Of course, I don't have async in that case. And if I now take a look at that where, then you see on the right-hand side that this does not take an expression of function, but it takes a function. So the C# compiler knows that in this case, there is no database. Nobody is there who could execute SQL. So it doesn't make any sense to compile this to SQL. The only thing that makes sense is compiling that to machine language and execute it in memory. While when we have up here entity framework and a database, it absolutely makes sense to translate that into SQL. We have to translate it into SQL because otherwise we couldn't send it to the database. And therefore, entity framework uses this expression of function magic. Complicated? Kind of. I know. It's a little bit of mind twisting if you hear it for the first time, with all this func off and expression off and something in memory and something translated to SQL. I fully understand that. We could even go further. The real professionals, they build these expressions at runtime. And maybe if we see each other next year in the next class and we have practiced many months in C# this year, I can show you how to build expression trees on the fly at runtime. But this is even more complex. For now, I just want you to understand the role of the C# compiler when you have a database compared to when you run things in memory. If you have a database, it uses expression trees, this object tree describing your C# code so that entity framework can translate this code into SQL. And if you have something in memory, no expression trees, just compiled lambda expressions, compiled down to intermediate language, compiled down to machine language. With that, we close today's lesson. Let's quickly summarize what we have learned today. We started with some experiments regarding to change tracking let's zoom in a little bit, then we can do a better thing here. We started with some experience regarding the change tracker, entity states, and things like that. Then we had two short ones. The first one was raw SQL. How to send raw SQL statements, reading and writing, to the database. Remember, here we had a very important thing, SQL injections. Never do that. The third thing were transactions. Transactions are the classical database transactions, but this time we wrote it with entity framework to make sure that either everything is written to the database or nothing is written to the database in case of errors. And last but not least, we used a little bit of time, half an hour or so, on expression trees, so you get a at least rough understanding what's going on behind the scenes, how entity framework manages to create SQL statements out of your C# code. I hope it was an interesting lesson. We have specified the time when we meet again in the Discord server, in the Teams meeting. There we will discuss all your questions, all your understandings. We will make sure that everybody understood what we covered so far. But with that, for this video, I want to say thank you. See you next week.